Good morning. I want to go to number 8 in the 101 on drug notes drug notes, whatever topic that we want to call this right here. And talk about 3 abnormal events that occur in the synapse. Now, let's review just for a few seconds about the synapse. Number 5 has us drawing and labeling the synapse. I'm going to put number 5 back up here. I may not label it, but I'm going to go ahead and draw it and everything. That's a synapse. That's the end of the philodendria. That's a synaptic gap, presynaptic membrane, postsynaptic membrane, okay? Now that is a synapse. And most of them will look like that. Most of them look just like that, okay? Now the synapse may be between neurons, maybe between a neuron and a skeletal muscle, a neuron and a cardiac muscle, maybe between a neuron and a cell. Doesn't really matter. There's a synapse there, there's a gap. There's a release of a neurotransmitter. We know the sequence of events that occur at the synapse. And number 7. Okay, now, let's take a look at some abnormal sequences of events, all right? The first thing is, the action potential arises down here, causes the release of neurotransmitter. It's stored in little vesicles right here. Neurotransmitter diffuses across the gap, attaches to the receptor site, and activates the target. That's the normal sequence of events. But what if we didn't or couldn't release the neurotransmitter? There's a disease, a common term called food poisoning, caused by Clostridium botulinum, that prevents the release of the neurotransmitter, causes paralysis. So one of the abnormal sequences of events right here is, this is probably the easiest way to do it right here, is Clostridium botulinum. I'll go ahead and write out Clostridium botulinum up here. C-L-O-S-T-R-I-D-I-U-M B-O-T-U-L-I-N-I-U-M. Botulism is a disease that it causes. Clostridium botulinum is a protein, is a bacteria, produces a protein that blocks the release of the neurotransmitter. Clostridium botulinum causes paralysis, because it prevents the release of acetylcholine, the neurotransmitter, because it prevents the release put it back over here because I don't know how far that field of view goes over there. Prevents release of of acetylcholine. Right? If you have no neurotransmitter, you have no target regulation at all. Now, another one right here is going to involve another Clostridium. They're not a good group of bacteria, okay? Another Clostridium and it's called Clostridium tetani. You probably can guess what it causes, but you may not know the pathology. We're going to talk about that in just a few seconds. Clostridium tetani, C-L-O-S-T-R-I-D-I-U-M, T-E-T-A-N-I-I. Clostridium tetani right here. Now, back to the normal sequence of events. Turn back your page to number 7. The last step, I believe, on that sequence of events is that the acetylcholine must be released. It must be broken down. It must be removed. We talk about an enzyme, acetylcholine esterase, ACHE, that breaks down acetylcholine and allows the target to relax. Well, Clostridium tetani produces a protein that blocks the effect of ACHE. So there's continued contraction, not a paralysis, but continued contraction. So what I want you to write down is Clostridium tetani causes continued contraction, causes continued C-O-N-T apostrophe D, you can abbreviate it like I did, continued contraction. Because BC, it prevents the action of ACHE, prevents the action of ACE, because it prevents action of ACHE. Okay? Now, it's Clostridium tetani. The disease is commonly called tetanus or lockjaw. All right? Now there's a third sequence of events in here that's abnormal. There's more than that, but we're just going to touch on 3 of them right here. What happens if I have no receptor site right here? What happens if I wipe out my receptor site? Well, if I have no receptor site, I have no target regulation. If I have no receptor site, I have paralysis. There's an autoimmune disorder called myasthenia gravis, which wipes out the receptor site, causes paralysis. So that's what I want you to write down. Myasthenia gravis, M-Y-S-T-H-E-N-I-A, M-Y-S. I might put it over here, I apologize for that. I just can't write that road anymore. Myasthenia, M-Y-S-T-H-E-N-I-A-G-R-A-V-I-S, myasthenia gravis, causes paralysis. Because it destroys the receptor site, for acetylcholine. Okay, I don't need the drawing, I just put the drawing up right of the elbows. Okay, the Clostridium botulinum, Clostridium tetani, myasthenia gravis. What they cause. What is the overall effect? It's either paralysis or continued stimulation, and why? I'll be looking for 3 answers in each one of those right there. Now, let's go into 3 regions of the brain. First, I'm going to erase this right here. Okay? That was number 8 that we just did. Number 9, and I'll get better at this, maybe not, I don't know. 9, 3 regions of the brain. Let me show you brain. This is a human brain, about the right size really. I'm gonna take it out of this right here. This would be my brain and my skull looking in that direction. I apologize if my hand's in the way, but I can't move my hand right there. This is the brain itself. Now, this is the cord that attaches to the brain. So what we have right here is the cord. Now, I don't want cord as a region right there. I don't want cord as a region, not yet. We haven't gotten to the answer right here. So the cord attaches to the brain itself. And that is the brain stem. So the cord becomes the brain stem. That's the first region I'm going to write down up here. The brain stem. All right. The brain stem. It regulates breathing and heart rate. Regulates breathing and heart rate. I won't even write that down because you can write that down. It regulates breathing and heart rate. Okay? Now, the reason I want you to know this is, if you are brain dead, if there is irreversible damage to the brain stem, and you are an organ donor, your organs can be harvested because you are brain dead. You can be put on a ventilator and kept alive for years. If you don't want this, get yourself a living will. Or even, I'm not so much worried about y'all, but your parents and your grandparents. And it's not an easy subject to approach, to ask them, Gramps, do you have a living will? Grandma, do you have a living will? Mom, do you have a living will? Dad, do you have a living will? I don't want to talk about it. That's probably what they're going to say. But you need to come back and say, please don't make me have to make the decision when something happens, or if something happens, okay? So ask them to consider a living will, if you would, please. It'll take away a lot of heartache. Anyway, the brain stem controls respiration and heart rate. Now, the back of the brain right here, this colored portion right here, it's called the cerebellum. That's my second portion I'm going to write down. This is the back of the brain here, called the cerebellum. It's not colored in us. Right at the base of the brain right here, called the cerebellum. C-E-R-E-B-E-L-L-U-M, cerebellum. I'm going to put that up here. Brain stem, cerebellum. C-E-R-E-B-E-L-L-U-M, cerebellum right here. It controls coordination. 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 And we take it for granted. When we walk, we just walk. When we walk, we just walk. Okay? Now, with cerebellum damage, we would have something called ataxia. We would walk drunk. Not that any of you have ever done that before, but maybe you've seen about it. Seen it, heard about people walking drunk, staggering. Because this, their staggering is not due to cerebellar damage, but people that have cerebellar damage, or even animals that have cerebellar damage, walk staggered. They have ataxia, all right? So I'd like for you to write down cerebellar damage right here causes ataxia, leads to ataxia, which is uncoordinated movement. So I would like for you to put down ataxia right here, coordination right here, damage causes ataxia. Damage ATAXIA, damage causes ataxia, okay? Now the third region of the brain is the largest region of the brain called the cerebrum, C-E-R-E-B-R-U-M. C-E-R-E-B-R-U-M. Now all I'm going to put up here is higher brain skills, thinking, emotions. Higher brain skills, thinking, and emotions, okay? That's what I would like for you to write down as far as the function of the cerebrum. A little easier to confuse cerebrum and cerebellum. That's one reason that we did the longer word first, cerebellum, coordination, cerebrum, higher brain skills, all right? Now, number 10 right here, name the lobes associated with the brain. Well, these lobes are going to be in the cerebrum. They're cerebellar lobes, cerebral lobes. See, I screwed that up myself right here. So name the lobes, and I will put it in there. Well, it's going to go just like this right here because this is the one that you're going to get right here. Name the lobes. So we're going to name 4 lobes in the cerebrum. 4 lobes in the cerebrum. That's number 10. Frontal, parietal, temporal, occipital. Frontal, parietal, temporal, occipital. Frontal,